A sealed steel canister is being used to store neon gas, which has an atomic mass of 20.2 atomic mass units. The mass of the steel canister alone is 12 kilograms, and it has an interior volume of 8 liters. There are 4.5 moles of neon gas in the canister, and the temperature of the entire system is 300 kelvins. So in part A, determine the pressure within the cylinder. So notice we were given the volume, the number of moles, and the temperature, so we can just use the ideal gas law, PV equals nRT, and just solve for P. So divide both sides of the equation by V. So the pressure equals N, the number of moles, which is 4.5, times R, the ideal gas constant, 8.31. The temperature, given in kelvins, is 300. The volume, this must be in meters cubed, and notice the volume is given in liters. And there are 8,000 liters in 1 meter cubed, so 8 liters is the equivalent of 8 times 10 to the negative 3 cubic meters, 8e negative 3, or 0.008. And when you plug all this in, you get an answer of 1.41 times 10 to the 6 pascals. For part B, the sealed cylinder is now placed in a large tank containing a mixture of ice and water at 0 degrees Celsius, or 273 Kelvin. Neglecting any change in the volume of the cylinder due to thermal expansion, determine the pressure of the neon gas after the cylinder and its contents have reached thermal equilibrium with the ice-water mixture. So, the volume is not changing, so we start with the ideal gas law, the combined gas law, P1 V1 over T1 equals P2 V2 over T2, and we cancel out the V1 and the V2. And we want to get the final pressure, so P2 equals P1 T2 over T1. The pressure was 1.41 times 10 to the 6 pascals times